So when we're doing limits, we have a bunch of strategies now that we can use. So we have graphs, we have tables, we have algebraic properties that we can use, we have strong over weak arguments for limits to infinity. We also have some established limits, and one established limit is this one here, sine x over x is equal to 1. So the rate, as x tends towards 0, the sine value, which is a vertical line in the circle, compared to the x value, which is the arc length, okay, those values tend towards each other. So that line here and this arc length out here, okay, as the angle gets smaller, that arc length and the red vertical line are going to tend to be the same, so it gives us a ratio of 1. So we can use this established limit with some algebraic properties then to solve some limit problems. So as x goes to 0, I know that I can, if I factor out some pieces here, I can separate this out into 3 sine x over x plus 2 times x. Okay, and if I take a look at this one piece here, I know that that piece is equal to 1. The limit of that is equal to 1. So I can write the limit write my limit notation. So the limit as x goes to 0, okay, this is going to be the same as the limit as of 3 over 0 plus 2. And I can solve that limit part separately. And that's going to be equal to 1. So I end up with the limit equals 3 over 2. Okay, so again, we want to graph, we should really graph these to just check our limits. And most of your examples are not going to have answer keys because you're expected to graph and just verify your limits through the graphs. Okay, so this one here, let's take a look at this. What can we do with this one? We need to get rid of the divide by 0. So we have, if I put 0 in, I'm going to end up with 18 minus 18 over 0, which is 0 over 0. So I need to be able to algebraically rearrange this to get rid of that divide by 0. So limit as h goes to 0, we're going to end up with 2 times 9 minus 6h plus h squared, okay, minus 18 all over h. I can see that if I multiply 2 times 9, that cancels out with a negative 18. So I'm going to end up with negative 12h plus 2h squared divided by h. Got my limit notation, so I need to make sure I put that in. The limit as h goes to 0. Okay, these h's cancel out, so I end up with no longer dividing by 0. So I'll just write one more step in here. Limit as h goes to 0 of negative 12 plus 2 times h. Well, now I can substitute in because I don't have a divide by 0. This is going to end up being negative 12 plus 0. So there's my limit. So this one here, same thing. I need to algebraically rearrange this to get rid of this divide by 0. So if I put in 0 here, I get 4 plus, that's going to be 6 minus 10 is 0 divided by 0. Again, problem. So I'm going to, again, just algebraically manipulate this and see if I can get rid of that divide by 0. And then I can evaluate this. So I'm going to end up with 4 plus 2h plus h squared plus 6 plus 3h minus 10. So I'm going to, oops, I was going to put that all over h. I'm going to get rid of the some terms here. So the plus 4 and plus 6 and minus 10 cancel out. The times h times h times h divides, is taken out by that divide h. So now simplifying that expression, I'm left with this. Limit as h approaches 0. This is going to be 2 plus h. I should have combined like terms, but I get 2 plus h plus 3. And then as I plug in 0 into that expression, my limit equals a value of 5. Okay, so that limit's equal to 5. So here you've been given some function notation, and then you've been given the limit in function notation. So I just have to figure, okay, what is f of 5 plus h? Well, limit the f of 5 plus h, so let me just write the limit first. Limit as h goes to 0. Okay, so f of 5 plus h, that means I'm just going to plug in 5 plus h into that expression. 5 plus h squared plus 3, and then minus, I'm going to do this part a different color. So there's my f of 5. F of 5 just going to be 2 times 5 squared plus 3. Let's put that in brackets, and that's all divided by h. Okay, so then I've got it all set up. Okay, so I'm going to end up with 25, 53 minus 53 is 0, divided by 0. Yeah, that's a problem. Okay, so I want to simplify this algebraically. It looks like that plus 3 and this minus plus 3 will cancel out nicely. So just do that first. And then I end up with the limit as h approaches 0. That's going to end up being 2 times 25 plus 10h plus h squared minus 2 times 25, which is 50. Okay, and then all divided by h. Okay, so then I can see that the 2 times 25 and the minus 50 cancel out. I'm going to write one more step here. Limit as h approaches 0. That's going to be 25. 2 times 25 minus 50 cancels out. I end up with 2 times 10h plus 2h squared all over h. Okay, I have these h's cancel out, and I end up with limit. Now we can compress some of these steps if you want, but I'm just writing out more steps right now. Normally I wouldn't write out all these steps, but so I end up with 20 plus 2h. After that denominator cancels out, I can now evaluate this limit by plugging in my h. So I end up with the limit is equal to 20. Okay, so this is applying these limit laws like we can use, help us with this one here. The one in the last video was using a graph to help us out. Okay, graph and some algebra analysis here. We have some established limits that help us out. We have algebraic rearrangements that can help us out. So there's a number of ways we can apply limits. Okay, we're going to really do a lot of this algebraic rearrangements in the next few classes, so we want to make sure we know how to do those.